In lesson 1, we're looking at triangles and other polygons, reviewing some of the names of the different kinds. And we'll also be talking about parallel lines and some of the angles that we get when a line crosses over some other parallel lines. So we're first going to do some picture definitions. And you don't even necessarily need to draw the pictures. If you just want to do 3 dash, what do we call any 3-sided polygon, everybody? And that's true whether it's equilateral or scaling, as long as it has 3 sides. Be careful on the next one. I'm only having that up there, any polygon with 4 sides. The sides may or may not all be congruent. The angles may or may not be 90 degrees. What do we call it just because it has 4 sides? Shout it out if you remember. Perfect. A little hard to spell, but Quadrilateral. No, I'm not giving you a spelling test on these, but good to try to learn how to spell these things correctly. Where these will come up, the book will say, you have a quadrilateral, and this is true. So you need to know that means 4 sides. And same for some of the others. What do we call it with 5 sides, everyone? It is indeed a pentagon. What about 6 sides? What are we going to call that one? And again, especially these ones with more sides get hard to draw, so I just do 6 dash hexagon in my notes if I were in your place. This one has 7. Does anybody know what we call it with 7 sides? Shout it out. You're very close. It is a heptagon. And I forget which is which out of the HEPT and SEPT. One's Latin based and one's Greek based, and I'd have to look it up to remember which is which. I think everybody probably knows 8 sides. It is an octagon. Anybody happen to know 9? What is it? Perfect. It is a nonagon. And when you don't remember it, you can just say a 9gon. Or when you don't want to remember how to spell it. What about 10 sides? And sometimes the book will tell you that it has 10 sides. Sometimes it'll just use the word. What is that one going to be? We pronounce it decagon, like decade. December, I know, but that's because of the letter that comes next with the C, with the E after the C in December. What about 12? What is that one going to be, Riley? It is a dodecagon. For all of the others, we are going to say 11gon, 15gon, I don't know, 97gon, and not try to come up with names for them. Most of the time on the ones that aren't real familiar, the book will do both, the actual name and the number of sides. So everybody got those down? Okay. We also talk about diagonals for polygons. Diagonals have to go from one vertex to any vertex that is not consecutive. In other words, not right next to it. So I can take and go from that vertex straight across to the other side. That's a diagonal. I can go from that vertex straight across there. From that vertex where I drew my green dot, those are my only 2 diagonals in this, excuse me, pentagon. Because if I tried to go to this vertex, that would just be a side. If I try to go to a vertex that is consecutive, that's right next to it, I get a side, not a diagonal. So just to be able to tell those 2 apart. Okay, parallel lines. Well, let's throw this into the formula list. We talked about it the other day, but like, whoops, we didn't get that one in, so let's add it now so that list is complete. Scaling means all three sides have different lengths and all of the angles have different measures. And then we'll talk about parallel lines. And parallel lines will be what we spend most of our time on today. Looks like we're almost okay for me to move on. So parallel lines are, for example, those two that go straight across. They can extend forever, and no matter how far they go, they're never going to cross each other. We mark those on a picture with matching little arrows. So you see my two little red arrows on those. Now, if I had a picture that had two other parallel lines besides these, maybe I marked the other ones with the single arrows. In that case, I'd mark these with a double arrow to say, I know these two are parallel to each other, but maybe not parallel to the ones I've got over here. When we then draw another straight line that goes through our parallel lines, we call it a transversal. I need everybody copying this down. No, this is not numbered, so it doesn't go in your formula list. It just goes in your notes. The next part, we're going to come back to that. Now, when you look at this picture, do not add these numbers yet. You're going to do that on the one we put on your formula list. But where this transversal crosses those two parallel lines, how many total angles do you guys see? Hold up some fingers for me. How many total angles do you see in that picture? And I'm mostly seeing 8s being held up. So 1, 2, 3, 4, 5, 6, 7, 8. And again, don't copy these numbers yet. We'll do those on the one that we put on the formula list on the next slide. But out of those 8 angles, how many of them look to you like they're acute? Hold up fingers. And of those 4 acute angles, do they look congruent or do they look like different acute angles? What do you think? Do they look like those 4 acute ones all have the same measure? They look that way. We can't, that's not a reason in math to say for sure. We're going to talk about reasons next. What about how many obtuse angles are there? And again, there are 4 of them. So first thing, and they're all the same. So when you have these parallel line problems, first thing you're going to be noticing is, oh, which ones are acute, which ones are obtuse. And on our next slide, we're going to be able to say those are all congruent, not for the same reason. Parallel lines is not a reason. We're going to have more specific reasons, and that's what we're going to work on the next slide. We will also be able to say when we have a picture like this in our book that these 4 obtuse angles are congruent. So maybe I'm going to want to say angle 1 is congruent to angle 7. They're both obtuse. Now I got to figure out why to write that reason down on my paper. But never say 2 and 3 are congruent. Never say their measures are equal because one's acute and one's obtuse. So think about it as you look at the picture. So let's move into our reasons. So what I want you to do right now, back to your formula page, just a line or two, don't number it, but just write in the label parallel lines and copy this picture with the numbers in those same places. Then as we go down through our reasons, I'm going to have you not recopy the picture every time. I have recopied it every single time, but I want you to just look at this one picture in your notes and you're just going to write down which angles are this kind, which angles are that kind, and so on. Alex? Take however many lines you need to draw that picture where you can read it with your handwriting. And again, people will finish this sheet of paper at different times. That's why I wanted to make sure you know the extras are over there. Some of you write really, really tiny, and it takes you a lot longer to finish the first sheet of paper. Some of you have larger handwriting, and you'll go through it faster. Alternate interior angles. What does the word interior mean? Everybody. Inside. So I'm talking about the angles that are inside the parallel lines. So I'm talking about 3, 4, 5, and 6. Does it look to you like all 4 of those are congruent? Or does it look to you like something's acute and something's obtuse when you look at that picture? What? So does everybody see out of 3, 4, 5, and 6, it looks like 2 of them are acute and 2 of them are obtuse? The 2 acute ones are alternate interior. The 2 obtuse ones are alternate interior. So you're not going to recopy the picture. You are just going to write this part. That says angle 3 and angle 5 are congruent angles. The equal sign with the squiggle means these shapes have the same measure. These shapes are the same size. We only use an equal sign between numbers or between an algebraic expression that means a number equals another number. When it's shapes, we use the congruent sign. So 3 and 5 were the 2 acute ones that were inside the parallel lines. 3's by the top one, 5's by the bottom one. 3's on the right, 5's on the left of the transversal. That's what we mean by alternate, beside the opposite parallel lines and opposite sides of the transversal. 4 and 6 are the 2 obtuse ones. And you may abbreviate that AIA, but you have to know it stands for alternate interior angles, or you're going to get mixed up on what letters you're writing down. Don't memorize it as AIA, memorize it as alternate interiors. What does exterior mean? Everybody. Outside. So now we're looking at the 4 that are outside the parallel lines. So out of 1, 2, 7, and 8, 1 and 7 are the acute ones. 1 is by the top line, 7's by the bottom, 1's on the left, 7's on the right. Similarly, 2 and 8, the obtuse ones, are also alternate exterior angles, and we abbreviate with AEA. And again, don't recopy the picture. Trying to save you some time and some writer's cramp here. Corresponding angles are probably the hardest one for students to really grasp what's going on with that. And what helps me with corresponding angles, I think of, what if my picture was a street map with 3 streets, and 2 of those streets cross right here, and maybe we've got a stoplight right here. And if I think about a map, 1's the northwest corner, 2's the northeast, 3's the southeast, 4's the southwest. Then I go to my other intersection, and the northwest was 1 up here, the northwest is 5 here, so 1 and 5 are corresponding angles. 1 and 5 are each above a parallel line, and they're both on the left of the transversal. That's what we're talking about with corresponding angles. So we need to write down these pairs in this case. So there's 4 sets of them now. Didn't mean to totally delete that. I just meant to move it down. Now, our next one, vertical angles. I know we've already done vertical angles. Way back number 1, I think, on our list. But so many times students forget about vertical angles when we have 3 lines in the picture. But it's okay to just look at a part of a picture. For example, if we just looked at that part, do you see the vertical angles 1 and 3 and 2 and 4 is another set of vertical angles? Don't forget vertical angles are a possibility just because you have an extra line in there. So Then we could look at just the bottom part of the picture. And so again, you are going to write down just these four because it's still for the same picture. The last one that we're adding on our formula page, you will need to draw a new picture for, because when we talk about proportional line segments, we're talking about 3 parallel lines and 2 lines that cut across. And with the ones up above this, we've been talking about the measures of angles. With proportionate line segments, we're going to talk about how long the pieces of the lines are. So that's why we need a new picture. It's talking about something different with this one. So we're going to have something like this where I have 3 parallel lines, and you see they all have their arrows on them. And that chops the 2 transversals up into pieces. And I'm looking at the pieces of the line segments marked A, B, C, and D. Now, you can tell some of these apart in the book because they're going to put a degree symbol on the ones where it's angles, and they're not going to have the degree symbol on the ones where it's the line segments, because sometimes it's hard to tell, is that A supposed to be this angle or is it supposed to be this piece of the line? But it doesn't have a degree sign on it, so it's going to be the line segment. A and B look like they're different lengths. One's longer than the other, and that's true. And you know, C slant, or the line over here on the right slants more than the line on the left. So C's even a little bit longer. Straight up and down is the shortest distance, and the more at a slant you go, the longer it gets. So none of those are equal to each other. What is equal is the proportion that we can set up. And I usually go along one line and say A over B, and then I go to the other line and do them in the same order, top over bottom, equals C over D. Some people prefer to go across first. A over C equals B over D, and that's also totally fine to set it up that way. If you cross multiply on those, you get AD equals BC for both. So then you would go on and be solving it from there, and you'd have the same problem that you're solving. Proportional line segments looks kind of long to me to write out as a reason. So either PLS for proportional line segments, or something like prop seg, if you want to write out a little bit more. But I'm not going to expect you to write out those 3 complete words. That takes up an awful lot of space. And with that, are you guys ready to solve some problems? Got a couple people still writing, so I'll wait just a second here. All right, looks like we can continue. So, are we talking about angles or line segments here? We're talking about the line segments. There's no degree symbols on any of that. So this one is going to be proportional line segments. So I can take on this side, top over bottom, 2 over 5 equals, and then on the other side, 8/3 over x. Want to be sure I remember that 8/3 is a numerator. I don't want to write it so that if the bell rings and I stop there, I come back and think it's 8 over 3 over x. I want to make sure I know 8/3 stays together. Now, when you're solving fraction problems like this, what do you usually do? Somebody, anybody, what do you usually do when you're solving those, Riley? Yeah, let's cross multiply, and then I don't have that quite such a messy thing with a fraction inside of a fraction. I have 2x equals 5 times my 8/3, or I can write it 40/3 if I want to. So then what am I going to do? I want just x, and I have 2x. Don't let the same 2 answer everything. Like, what do you do when you have a problem that says 2x equals and you want just x? A little bit louder for me. Well, how do I do that? I can't just move. I need to know how I move it. Divide both sides by 2. Except, you know, when I start dividing fractions, I get myself kind of messed up with that. So it may help to think about it another way. Jace? Isn't dividing by 2 the same as multiplying by a half? So I'm going to choose to write this one as I'm going to multiply both sides by 1/2. Then I have just an x over there, and this is easier to see that that is going to give me 20/3 for my answer. Let's move on to another example. So go ahead and copy the picture since this isn't in your book and you want to have it in your notes for reference. But we have these 2 parallel lines, and then we have a transversal going through there. And we are supposed to find all 3 of them. Now, what I find works best when I'm looking at these parallel line problems, I'm not going to mark up my book. I will mark it here on the smartboard. But first I look and see, okay, which ones are acute angles in there? And I'm not really going to worry about anything that's not labeled. Which ones do you see up there that are acute angles? Jace? A and C, and so I'm at least thinking, okay, those are going to be congruent because I've got the parallel lines. If I use that, I'm going to have to put a reason down when I get to working it, but first I'm just trying to figure out what's related to what. What about obtuse angles? What are my obtuse angles in there going to be, Clay? And so those are going to have to be congruent to each other. And so let's see, the A and the C have 2 letters, so that's not a good place to start. So let's start and let's write down, hey, we look at that and we see 2b and 130 are both obtuse. So we know 2b must equal 130, but we have to write down a reason if we write that equation down. So who can look at your formula list if you need to? And which kind of angles are that? Which one of those things will I write down as the reason for that? Caden. Vertical would be straight across from each other. So 130 and this over here would be vertical. For vertical, I had to take just 2 lines where they cross. I can't have that space in between. Ellie? They are corresponding. 130 is northwest, 2b is northwest, and I'm not going to just do CA, but enough that it's corresponding. Divide both sides by 2. Everybody shout out for me, what's B? And it does not need a degree sign since there is one in the picture. Okay, I can't just say A equals C, so I'm going to have to do something else to get A or to get C. Why don't we come up with something for A first? As you look at the picture, what can I do with A? I can't put down A's equal to another angle because I don't know about the other angle that it's actually equal to in there. Ayla? So we still have supplementary angles. Good job not forgetting about that. 130 plus A is 180, subtract 130, and the reason for that was supplementary. Subtract 130, everybody shout out, what's A? Now what can I do for C? I've said it out loud, I just haven't written it down yet. What can I do for C? Lucia? What did we already notice about C? So we already noticed that C was the same as A. Reason is corresponding angles. So that means C is also 50. So let's kind of see what we're doing with those. Okay, have a couple more here somewhere. There they are. Now we have a triangle problem. And we need to find X and Y in this. We're going to do it together, but you probably want the picture jotted down there. Who can tell me something to get me started with this one? Have anybody who hasn't answered something yet? Max? Why? Perfect. 145 plus x is 180 supplementary. So we have to subtract 145 on both sides. And what do we get? Shout it out, everybody. X is 35. And there was a typo on this. It really already had the degree signs in there. So X is 35. Now that I know X is 35 degrees, how am I going to get Y? What am I going to need to do with that, Tilly? And instead of writing out, because all of the angles in a triangle add up to 180, I'm going to say that is triangle sum and just write TS. But Tilly was exactly right with the reasons. So this is 75. So if I subtract 75 on both sides, everybody shout out, what do I get for Y? Are we good there? Last one, and then we'll do homework. So this tells me angle A measures 35 degrees. I am supposed to find the measures of the other two angles. What do these little tick marks mean? Marlo? That those two sides are congruent. So I've got an isosceles triangle. How does that help me with these angles I'm supposed to find? Allison? So it means A and C are the same number of degrees. So the measure of angle C is 35 degrees. And that's because we had an isosceles triangle. Now that I know both of those angles are 35, how do I get the measure of angle B? We did it before on the last problem. Alicia? We're going to do triangle sum. So we are now going to write down the measure of angle B plus 35 plus 35 is 180. So we subtract 70 on both sides. And the measure of angle B is, shout it out, everybody, 110. And we do need the degrees because that was not labeled in the picture. And I needed to write down my reason triangle sum for that equation.